Lecture 6.3. Using the Z-statistic to test a hypothesis, we can use the 8-step decision process. First step is to establish H0 and HA based on the claim. Second step is to decide which test to use, Z or T. Third is to set the value of alpha. The default value is 0.05. Fourth step is to establish the decision rule by calculating rejection region based on alpha. Fifth, gather the sample data. Sixth, analyze the data by calculating the statistic. Seventh, reach a statistical conclusion by comparing the observed statistic with the rejection region. Eighth, make a business decision. To illustrate the process, we will solve the problem with the known population standard deviation. The average net income for sole proprietors several years ago was $98,500. The population standard deviation is $14,530. Make decision on the claim that the net income figure has not changed or mu is equal to $98,500 by taking a random sample of 112 sole proprietor accountants to determine whether the net income figure has changed. Step 1. There is sign equal in the claim, so the statistical hypotheses are H0, mu is equal to $98,500, and HA, mu is not equal to $98,500. Step 2. Because the population standard deviation is known, $14,530, the sample size is greater than 30, and the researcher is using the sample mean as the statistic, the Z-test is the appropriate test statistic. Step 3. The type 1 error rate is not specified, so use the default value of 0.05. Step 4. HA has the sign not equal, so the rejection region is in the two ends of the distribution with 2.5% of the area in each tail, and hence the critical Z values are plus minus 1.96. Step 5. Gather the data. 112 sample mean is $102,220. Step 6. Calculate the test statistic. The sample mean minus the claimed mean over the population standard deviation over square root of the sample size is 2.71. Step 7. Conclusion. Because the observed Z, 2.71, is outside of non-rejection region of plus minus 1.96. Reject the null hypothesis, which is the claim. So, there is enough evidence to reject the claim. Step 8. The evidence gathered indicates that the population average had changed, increased because test statistic is greater than 1.96. On step 4 we define the rejection region with the help of critical values Z equal to plus minus 1.96 which correspond to the given value of alpha equal to 0.05. Instead of calculation these critical values of Z, we could calculate the area under the tails given the observed values of Z, given Z statistic of 2.71. If this area is less than alpha, as it is shown in the figure, then Z statistic is located in the rejection rejoin and we reject the null hypothesis. The same problem can be solved in week 5 Excel-based calculator. You enter the input data into the green cells and read the results from the yellow cells. We see that the test statistics is 2.71, which is out of the non-rejection critical interval plus minus 1.96. That is why H0 is rejected. The two-sided p-value is 0.007 is less than alpha, which is 0.05. It is another way we can reject H0. If we enter the input values into Collab 6, the link is in the description, we will have the same results as in week 6 calculator, plus the decision on the claim, enough evidence to reject the claim. The next problem illustrates how to solve one-tailed problems. The average out-of-pocket expenditure in the United States for a dental tooth filling procedure if a person is insured is $141. Suppose a researcher believes that such a procedure is more expensive now, and she wants to conduct a hypothesis test to confirm her belief. She sets up a study in which a random sample of 32 recent tooth fillings is taken from across the United States. The resulting out-of-pocket expenditures for such fillings are given below. Previous studies reveal that the population standard deviation for such data is $30. The value of alpha for her study is set at 0.05. Use these data and the 8-step approach for testing her hypotheses on these data. Step 1. Establish the hypotheses. Because the researcher believes that this procedure is more expensive, the claim is that mu is greater than $141. So, it is the alternative hypothesis. The null hypothesis is that mu is less or equal to $141. Step 2. Determine the appropriate statistical test and sampling distribution. Because the population standard deviation is known, $30, the sample size is greater than 30, and the researcher is using the mean as the statistic, the z-test is the appropriate test statistic. Step 3. Specify the type 1 error rate. Alpha is 0.05 for this problem. Step 4. Establish the decision rule. Because HA is mu at $141, then alpha equals 0.05 is in the upper tail of the distribution. Thus, the rejection region is in the upper tail of the distribution and contains 5% of the area of the distribution. It means that the critical value for Z is 1.645. The decision rule is that if the data gathered produce an observed Z value greater than 1.645, the test statistic is in the rejection region and the decision is to reject the null hypothesis. If the observed Z value is less than plus 1.645, the decision is to fail to reject the null hypothesis because the observed Z value is in the non-rejection region. Step 5. Gather the data. The 32 observed expense values are given. The sample mean of these data is $148.97. Use Collab 1. Step 6. The value of the test statistic is the difference of the observed and the claimed means over the standard error, or 1.5. Step 7. Statistical conclusion. Z equals 1.50 of 1.645, so the statistical conclusion is to fail to reject the null hypothesis. The same conclusion can be reached using the p-value method. P-value is the area under the distribution to the right of 1.5. It is 0.0668, which is greater than alpha. So, the test statistic is to the left of the critical value. We do not have to calculate that it is 1.645. We fail to reject the null hypothesis based on a comparison of the yellow and the blue areas. Step 8. Managerial implications. One might use the results of this study to argue there is little or no inflation in the area of dental work. Now we use the decision matrix and see that there is not enough evidence to support the alternative to the H0 hypothesis, which is the claim. Not enough evidence to support the claim that mu is greater than $141. The problem can be solved with the weak 6 calculator or with Collab 6. It was a right-tailed test mu at 141. For left-tailed tests the logic is similar, but the signs and illustrations are different. See, for example, the illustration for the left-tailed test and corresponding p-value. So far, we have been working with the z variable. We can work with the x variable as well. In the last problem, z critical is 1.645. The corresponding x critical can be found from the formula for the z-score. Z is equal to the difference between x and mu over standard error. For mu equals 141, sigma equals 30, and n equals 32, we have x critical of 149.72. If the sample mean is greater than this critical x, we reject the null hypothesis, otherwise, fail to reject.